has over 25 years of extensive experience in information security and computer crime. A master degree holder in information security and computer crime, is currently the Chief Information Security Officer of Telekom Malaysia, a registered technical expert of Laboratory Accreditation Scheme of Malaysia, and she was awarded Security Leadership Award in 2010. And without further ado, ladies and gentlemen, please welcome Yang Mulia Raja Azrina Raja Osman.
Right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Thank you for the kind invitation to the organizer. I'm happy to be here. Very inspired with the talk before this. Thank you. Very insightful. Right. Today, I'm sharing a bit of experience from over 20 years of working in cybersecurity. I've worked in many areas. One of the areas that I'm really passionate about is on the software itself, right? Now, software security has long been a challenge, for any industry that relies on digitalization, right? So this is definitely a challenge, and it is something that we want to change. And I've tried this by going into university, teaching, training the trainers, bringing in trainers who are experts in application security, and trying to develop a new generation of developers who understands security. I'm probably still not there yet, okay? But I'm still working on it, and I hope with the audience today, I hope I'll give you a bit of insight on what we face at the industry with regard to software security, right? Now, one of the key things I want to highlight is the challenge that we have in software development has always been the time factor. The business users are always wanting a solution yesterday, right? So it is always a race against time, and often the setback that we get is it's not properly tested. The minute the software goes out the door, it's not properly tested, right? So there's a methodology behind this in which we're incorporating, and we're seeing success. We are seeing improvement, changes, towards this, and this is what we call shift left. So I'm not sure if earlier there had been discussion on shift left security. I'm going to touch a bit of this towards the end, but first, let me cover somewhat on cyber resilience and why we're doing this. Why in software development we need to think about resilience. Now, it was interesting that coincidentally last 2 weeks or so, I read over LinkedIn, there was a post by a developer, and he said, why bother with all the frills in software development? When we develop software, just do it as what been asked. The user or the did not ask for this feature, why bother, right? So then came a long thread of discussion. Some saying, means that you're not future-proofing your solution. You're not embedding the best practice in your development and all sorts, right? So we have this situation where I think the understanding on cyber resilience perhaps are not quite common amongst all. When we're talking about applications for critical organizations, we're talking about applications that we develop for medical. We're talking about those that we develop for businesses, okay, that involves transaction. We're talking about applications for mission critical, operations. Those are critical. Those applications do not have the luxury of failing, right? Failure there at the application level means loss. It means monetary loss. It means reputational loss. It means loss of life in some aspects or some instances, right? So we now are talking about security in the light of cyber resilience. And what does that mean? Yeah? Resilience means that you are able to anticipate. You're able to anticipate what can go wrong, what kind of attack can happen, what kind of mistake can happen, right? So anticipating, you are able to withstand. If you are being hit, you know that your applications can sustain. You're able to respond, you know what to do, and your applications have the modularity and agility to adapt, right? So in security, we're dealing with that. Okay, we're dealing with that all the time. Yeah, attacks are there all the time. It's a matter of how resilient your solutions. The minute you put it up in the public, it's a fair play for it to be attacked, right? Right. So we're talking about business continuity, which has been for decades. Organizations know how to do this, but having to do it in an application is something else, right? We're talking about trust and reputation, as I mentioned just now. We're talking about financial impact that we need to cushion, that we need to sustain. And we're talking about having these controls, but not impeding and not stifling the growth and innovation. We want to encourage innovation, but there must be a framework that's guiding these developments, right? So I want to take an analogy of a home, right? So when you're building a home, you tell the architect, you tell the designer, you say you want a house, you want a 2-story, you want 2 bedrooms, 2 baths, you want an open concept kitchen, right? But do you tell them you need 4 beams or 4 pillars or 6, you need to sustain this, weight, and because it's located by the beach, then it must, deal with the salt, weather, temperature, and all that, the wind factor and all that? No, you don't, right? As an owner, I don't have that knowledge or that information to feed. I just tell them what I want to look, you want it to look like at the end, right? Now, the same with software, yeah? Software development in business users, and I've dealt with a lot of business users, they tell you what they want in the end, okay? Now, if I take that LinkedIn discussion that I just quoted just now, and if we are not guided by any framework or not adopting any best practice, yeah, you'll be building a sandcastle, right? The minute it gets hit, it's going to fall, right? It will serve a purpose for a period of time, but it's just not going to be resilient enough, right? So we have the owner giving the specification. We have the architect who built to spec. What it means is that when you build this, you must build according to standards, right? And when we build software, we need to build up to certain standards, right? So testers come in then. So what do we test? The common practice is we do the UAT, user acceptance test. We're testing A. So who's doing the test for B? And security and all that, right? So in Malaysia, we call it the CF. Your house is not ready, you won't get a CF, right? It'll be sealed, you can't live in that, right? So in application development, who makes the call? Okay. So in my situation, we have a team that makes the call, right? So if this software is not ready, it won't go live, right? So the testing is beyond user acceptance test. It involves, of course, performance tests, but it also involves security tests, right? So I'm not sure how many of you among here are familiar or have been involved in security testing. May I have, some put up hands, if any, been doing penetration testing or SaaS DAS, security application testing? Okay, all right, not quite there. All right, none. Okay, so then this will be an introduction then, right? Okay, now in statistics-wise, yeah, so we see vulnerability in third-party software is the top 3 that in terms of cost impact, vulnerabilities that basically are the root cause of data breach. Another is on the misconfiguration. Okay, cloud misconfiguration is one of the top 3 with regard to occurrence, meaning that it's a common error, it's a common issue that contributes to data breach. Okay. Now, both of these configurations and software vulnerabilities are key contributors that could be avoided. Really, it could be avoided. Now, the rest of the vulnerabilities, as you can see out there, are human-related. And human, that's another topic, not for today, right? The human factor, the weakest contributor, yeah, to the weakest factor, yeah, the factor that is contributing most, yeah, to incidents. But these 2 areas that I've just mentioned are areas that I believe that can be managed, that can be reduced, yeah, if we've put in the right measures, yeah. Now, so we saw just now third-party applications, vulnerabilities, yeah, due to third-party applications that organizations use, meaning that they did not develop it in-house, but they purchase, these are supplied, yeah, by third parties. Now, 12% of incidents, data breach, are contributed due to these software or third-party applications. What are the vulnerabilities, specific vulnerabilities that are contributing to this? This is the table. So the main one is unpatched. Unpatched open source vulnerability previously detected. Meaning, how many of you actually, when you develop applications or when you're testing the applications, you check what are the source of the applications, yeah, the SBOM, yeah, whether these applications that the third-party code that they're using in the code are good, or have some historical issues, yeah, security issues prior, right? Now here, what they're saying, the majority of it are due to known codes that are known with security vulnerabilities, but reused in application, and those are the applications that are commonly exploited. I think you're familiar with Log4j, for example. It's been used in many applications. When that vulnerability hit, everyone was scrambling, checking which application had that running, yeah, because it was so widely used, right? So that's one of the factors. Zero-day vulnerability, I would say difficult, yeah, but it's difficult to stop. However, if we were to develop applications that are aligned with best practices, we're addressing all the fundamentals practice in security in software development, you can avoid zero-day. You can at least reduce zero-day, right? Vulnerabilities. Right. Now, what's interesting in this study, this is a 2023 study, they discovered that by having DevSecOps adoption into the software development lifecycle, they can actually reduce or save costs in the application maintenance and support, right? So this, to me, is this is an important fact that organizations need to realize, especially if we are rushing, yeah, for getting the application out the door, right? By putting in more diligence, yeah, and controls and validation testing, you can have a better solution, okay, and reduce and avoid all the challenges. I would say patches, okay, hot fixes, and all that sorts, yeah. So building security into every stage of a software development and testing it regularly, yeah, is something not for me to say based on my own experience, but this is a proven study, yeah, by Ponmon. You can make reference to this study by Ponmon Institute, IBM. The speaker before spoke about AI, and I'll touch a bit about AI because I get asked a lot how AI and security is. And in application security development, AI is just another application. It will inherit the same vulnerabilities any software may have. And in developing, and a lot of organizations are building their own LLM, right? Developing their own in-house, ensuring that the data are actually within their control, within their organization, right? They build their own LLM. But that build needs to have the security measures that you apply for any other application. So when you build applications, you need to put in all the security measures, yeah, the same that I mentioned, to avoid all these known vulnerabilities, right? At the same time, AI also require additional measures, okay? And this is what we call data fencing. AI data fencing means, okay, that that there are certain data that are being put up, yeah, and being fed, yeah, to the systems. Now, these data need to be treated before it can be used, right? Now, there must be a framework to ensure that the data that are fed are being processed. For example, if you're feeding the AI with personal identifier information, you're feeding it with PII, you're feeding it with personal data, and you think that, you know, you can do whatever you want, okay? You can send a query and you expect the AI to know how to handle it. But what happens is somebody else may do a prompt and query, and that data may be spit out. And that's personal data, and basically it gets reused and maybe even changed, manipulated, okay? But it is a PII. Now in Europe, in Malaysia, we've got in Europe there's GDPR, in Malaysia there's the Personal Data Protection Act. Organizations are to protect personal data. So there is a need to ensure that AI knows how to handle PII. That when a PII goes in, it gets fed to them, they need to know how to mask it, or how to encrypt it, or how to de-associate it. Yeah, it needs to have that capability, else their data will be reused, right? So the use of AI must be used sparingly, must be used with framework, and this is to avoid data breach. And I think the headlines shows there are struggles by organizations and authorities who are trying to put a clamp on how these personal data are being protected with the with new technologies such as AI that comes about, right? So even basic applications, AI, generative AI, such as ChatGPT, Copilot by certain brands, can leak data if they are not fenced, if data are not fenced. Yeah? And these are often configurations, often involve incorporating frameworks, yeah? And it needs to be enforced, right? So why is software security testing is essential? I mean, it's necessary, yeah. We have this evolving threat, as I mentioned. Any applications that you put out there are subject to attack. And regardless of whether it is meant for public or not, the minute you put it out there in the internet, it's public. Okay? A lot of organizations or personal users think that when they develop applications, this is meant, there's no domain name, there's just IP, only I know that this is there, only I'm testing it, no one else know. Wrong. Okay? There are crawlers, there are scanners, there are botnets on the network that are scanning the network all the time and doing the discovery. And that discovery will lead to further digging and testing of the applications that you put out there, right? So there's definitely very highly motivated threat actors out there that will go the extra mile to target organizations. Yeah. Now, second is I mentioned just now was supply chain attacks. Supply chain attacks, I think you've seen in the past. The most recent one was not an attack, right? It was an error. The recent incident, I'm not sure if I believe all of you are aware what brought down the airport, the planes that prevented people from going to the hospital or getting treatment, failure of systems to register people, people stuck at the airport not getting their the tickets. What was the main root cause? I believe many of you are aware. It was a bad code that got into the update. Yeah. Now, what contributed to that? What contributed to that was testing. They did, okay, but further testing was required. So something was missed in the test, and that's the kind of impact that we can expect, especially for applications that are residing at the endpoints. Okay, so if the application is residing at a gateway, yes, there will be also major impact. If it's residing at the endpoint, at the PC, at the device, there's also impact. Yeah. So I think it allows us to take a step back and see how important resilience is when we talk about cyber resilience, how applications contribute, and that testing is essential and something that cannot be taken lightly, right? So we have challenges moving forward as well. There are emerging threats. I think organizations, we need to prepare ourselves for post-quantum algorithm, for example. These are preparations for future capabilities in which there'll be more computing powers to subvert, to break, to penetrate systems that we have today. And as such, the importance of us, ourselves, as people in the industry, as testers or developers, to ensure that we put in a lot more thought and discipline in the practice that we do or deliver. Yeah. On top of all that, okay, we also have regulatory requirements, as I mentioned just now. In Europe, it's GDPR. In Malaysia, it's the Personal Data Protection Act that recently undergone amendments. We also have a brand new law, the Cyber Security Act, that came in force last June, just July, last month. And these are all requirements that put more a higher bar, okay, with regard to digital solutions, right? So this is what we are facing today, and because of that, we want to ensure that the security, the solutions that we bring about have the security embedded, in it. I'd like to share one of a methodology, okay, and why I think this is important, okay. Now, when we're talking about shift left, people often state it as a shift left as in testing. But we have taken a step ahead in which shift left to us is from the design stage. So security come in early, comes in very early. We engage early, we bring it into the requirements, meaning that before, when the user comes with their requirements, they want a house, they want a 2-story house, they want a 2-bedroom, 2-bath. We translate that, okay, into that whatever application required, and we put in what we establish as security baseline. So there are a standard security baseline, minimal requirements that needs to be embedded in any software solution. Now, the framework that we use is the security by design, privacy by design. There are principles behind these. Okay, there are principles, for example, in privacy by design. What does it mean? There are about 7 principles. One of them, for example, is minimize data collection. You minimize the data that you collect, that you retain. And that in itself will reduce exposure, will reduce the investment that you need to protect the data, okay? Will reduce the potential human mistake in handling the data, and a whole lot of other things, right? So that's one principle, for example. So security and privacy by design is something that needs to be embedded from the very start. We built into the requirements technical specification on security. So requirements, for example, you've got a login, you've got a page for the user to use, there must be a login, you require a login, that login must be based on multi-factor authentication. Okay, so username password is a thing of the past. Okay, it's sunset. Okay, it's something that if you have any applications that, if it's not an important application, fine. But if it's an application that involves your financial transaction, your personal data, involves any form of important data, it must be with MFA. Why? Because any password is confirmed compromised. There's so many malware that is stealing passwords nowadays. you will know that it's on your laptop, right? So those are the baseline requirements that needs to be embedded early onset. Next is to embed that in the contractual requirements. Now, thirdly, we come to the development stage. Now, what we have embedded is that when developers develop, they test. It is not waiting for a dedicated tester to do that test. As they develop, they test. And I've worked with developers in startups, for example. When they do this practice, at the end, when at the end of the iteration, when they have an almost complete module, basically it's almost clean. Yeah, because they ensure the early detection of all these vulnerabilities. Now, what we discovered is that, right, we have this process in which once you develop the application, you embed the SAS, the software, the static application security test. At the end of certain module iteration, you conduct the dynamic application security test. And at that point in time, before going live, usually about 3 weeks or so before go live, they conduct a concurrent UAT plus security test. When we conduct the security test, we call it penetration testing, which is right at the end, right? This is when you finish with development, we conduct the penetration test. What we discovered is that when codes are being embedded with SAS-DAS and conducted with repetitive security testing, at the time of penetration test, we will not find any critical findings. Penetration test, there are categories of findings. The findings can be low, can be medium, can be high, can be critical. Okay? Critical findings are usually very major. When we have critical findings, we have to relook at the runaway. We have to look at the timeline, and we usually will not make it to the go live date. They need to reschedule. Why? Because critical finding means that there's some very fundamental issue with the code. If you're not doing session management, you're not doing IDOR mitigation. IDOR is insecure direct access, direct object reference. These are vulnerabilities that allow an attacker to bypass authorization or even authentication. It exploits the code directly, right? So when you have this kind of vulnerability, you have to actually re-look at the whole code and redo a whole lot of work. Now, this is why we want to avoid any critical finding at penetration test level. At the very end of the application development, we do not want to see critical findings. It's a bad sign, right? So if you have medium to high findings, it can be mitigated. It can be fixed, okay, somewhat quickly, right? But not critical findings, okay? So critical findings means that your application can be bypassed, access can be bypassed, your application can be taken over, or very major unauthorized changes can be conducted on the application. Those are very major issues, right? Now, what happens if we don't do the security testing during development and we go straight to penetration test, and then you have a short runaway to go live? What do you think will happen? They will do a workaround, right? They will do a workaround. And what does a workaround means? It's a temporary fix. It's not a holistic fix. It will break. Someone will find a way to subvert it, right? So that's workaround, and we do not want workarounds. Okay, so that is why when we applied this method of ensuring the SASTAS is done during development, we get a cleaner penetration test result. We don't see critical finding, and that usually is our test, our measure, yeah, whether it's good or not. And there are situations in which when you do the penetration test, there are critical findings, despite them saying that they've done SASDAS, ask for the report. And then you find out that the report was not, the test was not comprehensive, right? So it's a way of validating whether security has been embedded in the application itself, right? So this development cycle, the stage, the C and the D are critical phases, but I would say the development phase is the most critical. It needs to be done correctly, and they need to have the right tools. One of the things I've done in the organization is to build the platform for developers to ensure that they have the right tools. These are tests that can be automated, but they need to be equipped with the right tools. There are open source, there are tools that you can buy, but they need to be equipped. So having the right platform ecosystem for the developers and having the right tools will enable them to speed up this process and ensure that the code that you have at the end of the day would be free from major security gaps, right? Right. Now, post-implementation, right? Post-implementation, there's always a cycle of periodic vulnerability tests. Vulnerability assessment, VA is vulnerability assessment, PT is pen test, penetration test. There is a continuous cycle for this. Now, reason being is that the platform that applications sit on, they, over time, generate or produce vulnerabilities that require patches. So vulnerability assessment will identify that. The penetration test is required when they conduct changes to the code. So over time, there will be changes. They will do CR, there will be change requests, there will be modules, new integration, APIs that are connected. All these require that cycle of penetration tests, right? I just want to touch on what is it, yeah, the vulnerabilities that we're talking about, okay, the security vulnerabilities. So I touch on the top 10 OWASP vulnerability. Now, top 10 OWASP is something that over my 20 years, I've been using this as a reference, okay? Developers who are aware of this and embed the practice to avoid these common vulnerabilities, often, not often, will develop better applications, more resilience in their applications, right? If you notice, in the last decade, for example, injection is still one of the top 10. Injection attack is still one of the top 10. And I think you know, injection attacks are the most easiest, most common, And I mean, anybody can do this kind of attack. You need a proxy. You use some tools out there, Burp Suite, for example. You can already attempt these attacks, right? Other vulnerabilities, broken access control, very common, includes partly session management. These are also common issues, right? But one thing that came up new in this list, in the new 2021 version, and they're working on the 2024 version now, is the insecure design. Insecure design to me is very important, and I think this is something leaders in application development who are architects and designers in application development, chief testers. Yeah, these are things that you need to know with regard to design, software design. So when, for example, applications that have, I think now all applications have API requirements, how do you do that safely? How do you integrate with API safely, right? So that framework needs to be in place. OAPs provide API security guidelines, top 10, web security, mobile security. So these are guidelines that can be used as references, that when we conduct tests, these are essential things that you want to test before someone out there test it for you, yeah? Before some malicious users test it for you, right? So my last slide, okay? Just want to come back to the practices that can contribute the cornerstone to building a cyber resilience solution. Yeah. So I hope at the end of this, at least, okay, if there's anything that you can take away from this, would be at least looking up what is cyber or security by design, what is privacy by design. Yeah. Those are principles that, to me, needs to be translated into framework in application development, translated into testing requirements. That would make a better world in the digital world, yeah, if these practices are indeed embedded, yeah. We also emphasizes on reducing threat exposure. And this is something in which in security practice, it is a common practice in which access is granted to those to least privilege. Yeah? There are controls ensuring authorization, controls for authentication. Those are basic practice to ensure the first front door to your application, yeah, is guarded, right? So reducing threat exposure is very essential, because you can have a very soft and weak application, but you can at least have a strong layer of access to reduce the impact while you actually do the relevant fixes inside, right, in the application itself. So this is the, finally I want to mention about the shift left, yeah, security. Something that we have seen that it worked, okay, and I think more organizations should be adopting this, okay. And as such, there's a certain level of expectation that we put to vendors that are serving organizations, especially critical organizations, that they need to meet a certain hygiene. They need to meet the certain baseline requirements that we put as a requirement. And that's partly to ensure that whatever solution they bring to the organization are resilient. Yeah. So, yeah, that is the end of my slide. Thank you. I'm open to any questions. Thank you. Oh. Question. Okay. You can have my.
So thank you very much for the great talk. My name is Trink, so I'm coming from a German software company. We're also doing securities in my company as well. So basically I have two questions. So, you know, I am not a native security guy by nature because I don't work in securities. but I work in the platform team. We are some from time to time that we need to touch a security topic for the whole product we are developing. So one of the first question I have is, if we try to integrate a lot of security tools, Dust, SAST, or SCA tools, and if we look into all out there from the open sources, it's a huge amount of tools to be selected and so on. And then it's always difficult to choose one of them, remembering when the SBOM being pushed by the log4j 1.5 years ago, and everyone, okay, what format we are choosing for SBOM and so on. And then one of the sentence that head of the security guy in my company said that is always stick in my head is, regarding to the securities, one good report is so much benefits for then a lot of not so good security report. Then my question is, from your organization and from your experience, how would you select tools and how to make the good report from the security testing?
Right, good question. When one of the first thing I did when I took up this job really was to look at the test report. I asked for the test report. So often a particular application, which is a very critical application for the organization, so I said I want to see the test report. Now what am I looking for? In a test report, we are looking for, firstly, comprehensiveness, whether they actually test the critical things that they should be testing. That's one, the scope of it. Whether they use the right tools and all that. Secondly, we want to make sure that the findings may be right, may be there, but the recommendation matters. What did they put in the recommendations? Now, a lot of situations when people look at test reports, they're just addressing the recommendation, addressing one factor of the recommendation. So the recommendation says you are revealing your passwords in the code. Your password is in the clear. You're not using any encryption. It's in the clear. So what they do, okay, we'll encrypt this password. But there's like a bunch of other passwords in there, not detected, of course. When you do tests, you do sampling, right? Those are not fixed. So you fix that one particular finding, okay? So it's not a holistic fix. So that's one of the major issues. Secondly, the fix is the recommendation itself, whether it's the right recommendation for that environment, for that application, right? So there are many ways of putting your passwords or securing your password. You can secure the password in a key management, KMS, key management system, where they have the right tooling for the encryption and all that. You should not be keeping a static password. Even if you encrypt it, it is still a static password. Is that the best way of doing it? Is that the only way of doing it? Yeah. So those are the kind of in the recommendation, you need to put out those questions. Yeah. Is this a machine-to-machine access, or is this a human-to-machine access? Is it interactive or non-interactive? Right. So is this password used by machine? Right? If it's a machine, then can we have a PKI kind of async kind of handshake? Or can it use some KMS? If it's a human interactive application, then that password, how do you want to handle it? It shouldn't be stored in the first place, okay? But where is it handled, right? So if it's going and authenticated by another system, that system should not be storing either, right? So there must be some MFA additional to that, so that even if in the event that passwords are stolen, they can't hack the system because they need to steal your phone, right? In order to do the MFA. So those things needs to be put in the recommendation. So if the recommendations are just telling you that, okay, this password needs to be encrypted, that's it. And oftentimes the corrective measure is not holistic. So that's where my belief is that we need to put more context, we need to put more threat modeling, and more practical recommendations that is relevant for that application, depending on how complex that application is. Yeah. So that's where my view. I've seen a lot of test reports, and those are the kind of feedback that I give, and that's when I said we need to do a shift left. We need to get the developers to do this. We need the architects, the chief developers to come up with framework. How we're going to do input validation. How many of you are aware how this input validation works? Yeah. I mean, this is like the most fundamental thing when doing web development, input validation. And if we don't have a framework for that, testers should be highlighting that. Where's the input validation? Not saying that, this particular variable shouldn't be alphanumeric, it should be decimal only. No, you should be asking, where's the input validation framework? Right? That's my view. It should be, we should correct it all around, not that one tiny piece of module, right? And when I speak that language to the chief developers, they get it. They get it. And they start developing frameworks. So this framework means any input coming from the user to the server must go through this framework. It must not go direct. It must go through this framework. So this framework is the one that you maintain. They need to maintain only one framework for input validation. Everything is there. So if you're asking for phone number, let's say, the application better be checking just decimal. If I'm a hacker, how I will break it? I will not enter a phone number. I will enter a query. Okay? I will first test with some strings, see what the server responds. I get some response, I'll do more. That's how people hack, right? So that's when they test. They say, oh, there's no input validation framework in this app. I can start poking here and there and get different results, right? But if you have an input validation framework, whatever thing that you send that does not meet the requirement, you send a standard error. So it will always be a standard error. You enter a phone number, the system asking for phone number, you enter a name, it will tell you, no, we do not accept this input, right? So you get a standard. So the hacker will not be able to learn much. They can't find their way, right? So that is what I mean by holistic approach. When you're doing a report, that's the kind of insight I look for. Right. Okay, good question. Yeah. Does that work?
Okay, can you hear me, right? Okay, so I just have a question. So let's say from a testing report, let's say in the report itself, they raise some false positive issues. So how do we manage or resolve that kind of issues? And how do we prove it that is really a false positive?
Okay. You are in the report, you get a false positive. So to me, validating it is through tests, right? So when we test, we need to do screenshots, evidence-based, right? So from there, and repetitive tests that producing the same result, then that is something that they need to take back and fix, right? Yeah. So to me, that evidence is important. Evidential support, yeah, to ensure that people don't have to repeat the test for you, and if they do have to repeat, at least they know what to look out for. Yeah. So in reports, I also always insist on evidence-based. Yeah. And tools today, yeah, that you use often are very specific in which line of code that's having this issue. It will be able to spit out that kind of specific findings, and that will help you mitigate in a more holistic approach, lah, right? Okay. But what your question triggered me is in a test, okay, when you do a UAT, for example, yeah, it's always in a positive flow, right? When you test, it's a positive flow. Means if there's a button and then you click yes or no. If you click yes, this is going to happen. No, this is going to happen, right? But for an attacker, we don't test that way. I'll be looking at the URL and I'll try to inject things. I'm not going to hit the button in the web. Okay? Yeah, sorry about that lah. I mean, that's how we security people think. Yeah. So when you do that test, you need to inspect every aspect of it. So you need to inspect what's being passed, what variable is being passed in the URL, because that is an exposure as well. Okay. So it's not just looking at the UI, UX, what is there, but you need to see as well what is the data that's being passed, yeah, in the URL, in the code itself, because I can be using a local proxy, and I can see everything that you're passing, even if you're not displaying it, yeah. So we need to think from that angle when we develop, yeah. So with user interface, less is more, really, when it comes to data. Less data that you send out to the user is better, okay? That is the best way to deal with it. Use flags, use indicators to identify and track. Don't start passing all the personal information across, yeah? So, yeah. Thank you for the question. I hope I answered your question. Okay. Right. That's it. Any more? Thank you. Thank you so much.